Hello everyone, I welcome you to my channel, that is HKB Maths classes. Today we'll solve questions from Exemplar, and this video will be very short. We'll be solving very few questions, and slowly we'll be taking questions with more difficulty level. And let's start. Okay, the first question for today's video is that evaluate tan inverse root 3 minus sec inverse minus 2. So this is a very simple question, and this may carry 1 or 2 marks. Okay, tan inverse root 3, and here we'll be using the property, that is we have one property, sec inverse minus x. This is pi minus sec inverse x. So we'll be using that property, that is minus, that is pi minus sec inverse 2, and we'll now simplify the tan inverse root 3. It's as we know it's pi by 3, then we'll just multiply, it's minus pi and plus sec inverse 2. So this is pi by 3 minus pi, and we know that sec inverse 2 is also pi by 3. So and if we simplify this, okay, then pi by 3 plus pi by 3, 2 pi by 3 minus pi. So which is equal to 2 by this is minus pi by 3. So 2 pi by 3 minus pi by 3 is equal to minus pi by 3. So let's move to our next question. Okay, what's the question? Find a value of sec tan inverse y by 2. So we need to find a value of this. Okay, to find the value of this, what I'm going to do is this tan inverse y by 2. So just assume let tan inverse y by 2 is theta. So if you assume theta, so that means we need to find the value of sec theta. So we can simplify this, that is y by 2 is equal to tan theta. And we know that 1 plus tan square theta is equal to sec square theta. So this implies 1 plus tan square theta is y square by 4 equal to sec square theta. Okay. Now from this we can get the value of sec square theta, that is sec square theta is equal to that 4 plus y square by 4. Hence sec theta is equal to under root 4 plus y square by 2. So if you take the square root, this is under root 4 plus y square, and square root of 4 is 2. So this is sec theta. But what you need to find a value? You need to find the value of sec tan inverse y by 2. But here theta is equal to tan inverse y by 2. So finally you can write that therefore that sec tan inverse y by 2 is equal to under root 4 plus y square by 2. So this is again equally a very simple questions. Okay, and these are the questions are given as important examples in in Exemplar in class 12. And from there we'll be selecting a few questions, and slowly then we'll go to exercise. Okay, find the value of 10. So this is another important question. Find the value of 10 cos inverse x. So we need to find this value 10 cos inverse x, and using this value, so we can express this value 10 cos inverse x in terms of x. So using this value, hence evaluate this. So using this value we need to find the value of 10 cos inverse 8 by 17. So we can just solve this. Again, it has very less number of steps. So let's assume cos inverse x. Let cos inverse x equal to theta. So cos inverse x equal to theta. This implies x is equal to cos theta. X is equal to cos theta. Now what do you need to find out? We need to find out the value of 10 cos inverse x. But cos inverse x is theta. Therefore, we need to find out the value of tan theta. Tan theta. So tan theta is sine theta by cos theta. Right? Cos theta is x. So sine theta also you can write in terms of x. Sine theta is the under root 1 minus cos square x. Cos square x means x square. So we can write tan theta in terms of under root 1 minus x squared by x. Okay, so now therefore tan theta, what is the value of theta? Theta is cos inverse x. So cos inverse x. So that is equal to under root 1 minus x squared by x. So based on this expression, that is tan cos inverse x, we have expressed in terms of x. So now what I'm going to do is we need to evaluate tan cos inverse 8 by 17. So we can replace x by 8 by 17 and you can get the value of this tan cos inverse 8 by 7. So we can now find the value of this expression. Therefore, tan cos inverse 8 by 17 is equal to, so we'll be replacing x by 8 by 17. This is 8 by 17 and this is 1 minus x squared. X squared means 8 squared by 17 squared. 8 squared by 17 squared. So if we simplify this, expressions, this is 8 upon 17, then if we simplify this, this is 17 squared minus 8 squared by 17. So we'll take the square root now. Okay, this is 17 squared. So if you take the square root of 17 squared, it will be 17. So you can bring it to the denominator, and denominator already 8 by 17 is there. Okay, and now 17 squared is 289 and 8 squared 64. So we can cancel this. Okay, we can cancel this, and finally 289 minus 64, this comes as 225 by 8. So this is equal to 15 by 8. So that is the value of tan cos inverse 8 by 17. So let's move to the another question, that it proved that 2 sine inverse 3 by 5 minus tan inverse 17 by 31 equal to pi by 4. So this is also a very simple example given. Okay, prove that this expression is equal to pi by 4. So just start with the left hand side. Left hand side is 2 sine inverse 3 by 5 minus tan inverse 17 by 31. Now in step 1, what I'm going to do is this expressions, that is sine inverse 3 by 5 will be expressing in terms of tan. So if we that we know that sine means perpendicular by hypotenuse. So if we express in terms of the right triangles, 3 by 5 perpendicular by hypotenuse, so the base will be 4. So using this triangle, we can write sine inverse 3 by 5 in terms of tan. Okay, so that is equal to sine inverse 3 by 5 is tan inverse. Tan means perpendicular by hypotenuse, so it is equal to 3 by 4. So we can actually show that sine inverse 3 by 5 is equal to tan inverse 3 by 4. I know like all of you have done this, so therefore I have written directly. So minus, so tan inverse 17 by 31. Yes. So now this is 2 tan inverse 3 by 4. So we have a formula 2 tan inverse x. 2 tan inverse x is tan inverse twice x 1 minus x squared. So this is a very useful formula. So we are going to use this 2 tan inverse x. 2 tan inverse x. So that is equal to tan inverse twice x 1 minus x squared. X squared means 9 by 16. Yeah, 9 by 16 minus tan inverse 17 by 31. Okay, 17 by 31. So next step, we'll simplify now. Tan inverse. Okay, we can cancel this. So this will be 3 by 2, and this is equal to 16. Then 16 by 9. This will be 7. Okay, right? This will be this is 1 minus x squared. In fact, this is the square root is not required. So like this is 1 minus x squared. that is 9 by 16. Yeah, this is 9 by 16. So this is not required because twice x 1 minus x is squared. So this gives us 16 and 7. Fine. So this will be 3 by 2 by 7 by 16. Okay. Then minus 10 inverse 17 by 31. Yeah. So in this place, initially I have written twice x under root 1 minus x squared, which is wrong. So we have to use the correct formula. Now we'll just simplify this. So 10 inverse. Okay. This is, you can cancel 16, right? You can cancel 16. So if you cancel 16, so then this is 3 by 2, then 16 by 7 minus 10 inverse 17 by 31. So you can cancel this 8. So this gives us 10 inverse 24 by 7 minus 10 inverse 17 upon 31. So we'll be using now 10 inverse x minus 10 inverse y formula. Okay, 10 inverse x minus 10 inverse y. So 10 inverse, okay, so the formula is 10 inverse, okay, 24 by 7 minus 17 by 31, 1 plus 10 inverse a minus 10 inverse b is 10 inverse a minus b by 1 plus 24 7 into 17 by 31. Okay, and if we simplify this, so this is equal to 10 inverse. So if you take the LCM, this is 7 by 31 and 7 into 31 plus 24 into 17 and 24 into 31 minus 7 into 17. So 7 into 31. So this one you can cancel it, and only 1-2 steps left out. That is 10 inverse 24 into 31 and minus 7 into 17, and next 7 into 31 plus 24 into 17. Fine. Only that we need to calculate this. So if we take the LCM 7 into 31, so it comes to 24 into 31 minus, this is, okay, this is 17. Yeah. So it is 7 into 17 and the LCM will be 7 into 31. So in the denominator also it's 7 into 31. So it comes in this place, it is 7 into 31 and plus 24 into 17. So now we need to calculate this. So if we simplify these expressions, it comes as 10 inverse 625 by 625, that is equal to 10 inverse 1 and 5 by 4. So hence proof. So these are the very simple questions but are very important. Okay, so we use simple rules, simple properties of inverse trigonometric functions, and you can just prove this, and it will definitely help you for your preparations for your exams, especially that boards. Okay, and thank you so much for watching my video, and please keep watching, and I'll be uploading next video on the inverse trigonometric functions with taking some more important questions from exercise. Okay, and thank you. And in case if you are not subscribed the channel, please do subscribe the channel, and thank you so much.